In third session of the series, important points to study for +1 chemistry examination, we will discuss 3 chapters. Chapter 9, hydrogen. Chapter 10, the S block elements. Chapter 11, the P block elements. Chapter 9 is hydrogen, which is a small chapter. Similar types of questions used to come from this chapter in examinations. Students should learn the occurrence of hydrogen in nature, its position in periodic table, its physical properties and other characteristics such as electronic configuration, electron gain enthalpy, ionic and atomic radius, and most important, which is the existence of 3 isotopes of hydrogen and their mass numbers. Next topic is preparation of hydrogen. One should know both laboratory and industrial preparation of hydrogen, how zinc can be utilized to prepare hydrogen with the help of either hydrochloric acid or an alkali, and both reactions are given here. For the industrial preparation of hydrogen, electrolysis of acidified water, brine solution or aqueous barium hydroxide solution, and how it leads to the formation of hydrogen. But the major industrial preparation of hydrogen is done by the reaction of steam on hydrocarbons or coke at high temperatures in the presence of nickel catalyst, which is shown here. Related to chemical properties of hydrogen, first point is bond dissociation enthalpy. And the student should know the reason behind the high bond dissociation enthalpy of hydrogen-hydrogen bond, which is the highest for a single bond between 2 atoms of any element. Reaction with nitrogen to form ammonia and metals to form metal hydrides and halogens to form hydrogen halides and oxygen to form water are a set of important reactions of hydrogen. Hydrogen is also used to hydrogenate unsaturated vegetable oil to saturated vegetable oil or fats. Hydroformylation of olefins, water gas, producer gas are also important topic comes under this session. Another class of compounds of hydrogen is hydrides, and one should know the classification of hydrides, which are ionic, covalent and metallic hydrides. In each type of hydrides, you should be able to write about the stoichiometric ratio of elements, which type of elements form hydrides, their characteristics such as crystallinity, conductivity, volatility and physical state. In the covalent or molecular hydrides, you should be able to classify these hydrides based on relative number of electrons and bonds. Also, you should be able to tell the reason behind the use of metallic hydride for hydrogen storage and as a source of energy. The major compound of hydrogen is water, and you should be able to discuss both physical and chemical properties of water. As we know, water has an important role in biosphere. Which properties makes water to play a key role in biosphere? Questions come regularly in examination about the structure of water and the properties due to its structure. How the physical properties of liquid water and ice are different. You should know how to draw the structure of water and give its bond angle and bond length. Questions such as why the bond angle of water is 104.5 degree, which is lower than that of 109 degree 5 minute or 109.5 degree. What is the reason behind high boiling point of water compared to hydrogen sulfide? Why hydrogen bonding exists in water and how the hydrogen bonding affects the properties of water. Next topic is few important chemical reactions water can undergo. In this topic, questions such as show the amphoteric nature of water using equations, how it reacts with the electropositive elements and lead to the formation of hydrogen, why it shows hydrating tendency and makes hydrates, Next topic is hard and soft water. In this topic, student is expected to learn reasons behind hardness of water, differentiate temporary and permanent hardness, how temporary hardness can be removed from water using boiling and Clark's method, how permanent hardness can be removed using washing soda, ion exchanger and synthetic resins. Next topic is another oxides of hydrogen, which is hydrogen peroxide. In this chapter, one should know the oxidation state of oxygen in hydrogen peroxide. Both laboratory and industrial preparation of hydrogen peroxide are also important. In its structure, bond angles and bond length and how these are different in gaseous form and solid form. Most important point in this topic is oxidizing nature of hydrogen peroxide, and students should know at least 2 examples where hydrogen peroxide is used as an oxidizing agent. Hydrogen peroxide also acts as reducing agent in few reactions such as reaction with the HOCl and reaction with iodine. Hydrogen peroxide is generally stored in wax-lined glass or plastic vessel in dark. What is the reason behind it? Last point in this topic is the uses of hydrogen peroxide in different fields. Last topic is the preparation and uses of D2O along with the use of hydrogen as a fuel and its uses. In previous years, questions are repeated about the physical states of water and ice, preparation of hydrogen peroxide, questions related to structure and properties of hydrogen, water and hydrogen peroxide, preparation and properties of hydrides, reason behind the hardness and how to remove hardness, storage of hydrogen peroxide and are also repeated in previous exams. Chapter 10, the S block elements. First you should know the members of first and second group elements and why they called as S block elements. Why first group elements are called as alkali metals and second group elements as alkaline earth metals. We'll start with alkali metals. In this topic, we will start with these questions. Why ionization enthalpy of alkali metals are lowest among the periods in periodic table, why ionization enthalpy decreases down the group in alkali metals, why lithium ion is mostly hydrated compared to other ions in alkali metals family, why alkali metals and their salts show color in oxidizing flame. Those colors are given here. Topic is chemical properties generally alkali metals do possess. In this topic, first point is oxides of alkali metals. Types of oxides of alkali metals. Lithium only makes monooxide. Sodium forms both monooxide and peroxide. Potassium, rubidium and cesium can form both monoxide and superoxide. Among alkali metals, only lithium can react with nitrogen and it forms Li3N. Alkali metals react with water vigorously and form their hydroxide. They react with halogens to form halides, and except halides of lithium, others are ionic in nature. They possess good reducing characteristics which can be explained using their low standard electrode potential. What is the reason behind the color formation when alkali metals react with liquid ammonia, which are also important topic. Also, the types of oxoacids alkali metals can form. That is also an important session coming under this topic. Lithium shows anomalous behavior compared to other alkali metals. In this topic, students should know what is the reason behind the anomalous behavior of lithium and which are the properties of lithium different from other alkali metals. Explain the reason behind the similar properties shown by lithium and a second group element which is magnesium, which are the common or similar properties of lithium. Under the topic which is the major compounds of sodium, students should know the uses, formula, preparation of sodium carbonate, sodium hydroxide, sodium chloride and sodium bicarbonate. Last point is why the presence of sodium and potassium is very important for human body. Next session is group 2 alkaline earth metals. The members of alkaline earth metals, their atomic number and electronic configuration, students should be able to write. Why the ionization enthalpy of alkaline earth metals are higher than those of alkali metals. Why the tendency to form hydrides are higher in alkaline earth metals compared to alkali metals. Which alkali metals and their salts show color when they are in an oxidizing flame. Basic knowledge about alkaline earth metals reaction with oxygen, halogen, hydrogen, ammonia and their reducing nature. Nature of the oxides and hydroxides of alkaline earth metals. Why only beryllium halides are covalent and other alkaline earth metals are ionic in nature. Why beryllium shows anomalous behavior compared to other alkaline earth metals? Which are the properties of beryllium which is different compared to other alkaline earth metals? Why there is a diagonal relationship between beryllium and aluminium? Which properties are similar for beryllium and aluminium? Uses, formula, preparation of industrially important calcium compounds such as quicklime, slaked lime, calcium carbonates and calcium sulfates. Chemical composition and principle behind setting of cement, importance of gypsum in the setting of cement, and the last point, importance of calcium and magnesium in human body. In previous years, questions such as preparation of important calcium and sodium compounds, anomalous behavior of lithium and beryllium and diagonal relationship between lithium and magnesium and beryllium and aluminium. Structure of beryllium chloride, composition, preparation and setting of cement were also repeated in several examinations. Chapter 11, P block elements. We'll start with the position of P block elements in the periodic table. How the metallic, non-metallic and metalloid elements are positioned in the periodic table. Next topic is inert pair effect. The occurrence of oxidation states 2 unit less than the group oxidation states are sometimes attributed to the inert pair effect. Group 13 elements, the boron family. We should know the members of boron family, their electronic configuration and their existence in nature. Aluminium shows +3 oxidation state, while the gallium, indium, thallium can show +1 and +3 oxidation state in their compounds. You should be able to give the reason behind the different oxidation states shown by these elements. Why boron trifluoride is known as the Lewis acid? Explained with the help of its structure. Boron trichloride can easily react with ammonia. What could be the reason behind it? There will be oxide formation on surface when they react with either atmospheric air or with an acid. Acidic, basic, amphoteric nature of different oxides of boron family. Very important point. Why boron shows different characteristics compared to aluminium. Preparation, properties and uses of compounds of boron such as borax, orthoboric acid and diborane. Structure of diborane and borohydrides, very important point. And the uses of boron family members in different applications are the last point related to boron family. Group 14, carbon family. You should be able to tell who are the members of carbon family, their electronic configuration and their existence in the nature. And we should discuss about the electronegative behavior the carbon possess. Different oxidation states of carbon family members, oxides of carbon family members and the properties of their oxides, halides of carbon family members and their characteristics, why carbon shows anomalous behavior compared to other members in carbon family, why carbon has different allotropes such as graphite and diamond, what is catenation and why carbon shows that property catenation. Different allotropes of carbon, how they are different in their properties. Preparation, properties and uses of compounds of carbons such as carbon monoxide and carbon dioxide. Characteristics and preparation and properties of water gas or synthesis gas, producer gas and dry ice. Also, you should be able to write about greenhouse effect and you should be able to describe the formation of metal carbonyl compounds and their characteristics. Structure, preparation, properties and uses of compounds of other carbon family members. Main compounds are silicon dioxide, silicones, silicates. You should be able to discuss their structure, their properties and their uses. Uses of zeolites, especially in environmental remediation, is also an important topic, comes under carbon family. In previous years, questions related to structure of dibrine and its characteristics, properties of halides of boron family members, questions related to preparation and uses of water gas and producer gas, poisonous nature of carbon monoxide and greenhouse effect due to carbon dioxide, anomalous behavior of carbon. These questions repeatedly comes in the examinations. Characteristics and preparation of compounds such as borax, silicones, silicates, acidic character of halides of boron family members and allotropes of carbon also came several times in previous examinations.